Alright, so in the last video we practiced just finding generally the form of what y p, like the particular solution part, would be for these non-homogeneous differential equations. This one we're going to go over. Pretty good example, I'd say. It's going to be long though. Gonna touch some parts that we haven't gone over yet, but we'll definitely want to practice this some more outside of this video, but we have some initial conditions here, and it's going to be a long, painful process, but we're going to jump right into it. So we know that our final solution equals the complementary part, also known as the homogeneous part. So you can see this as y sub c or y sub h, but we'll just say y sub c plus the particular solution part. So this we've done a while ago with homogeneous equations, like it equals 0 and you factor out, and then this is like where you guess. But let's jump right into it. R squared plus 4r plus 4. So 2 times 2 and 2 plus 2, so this is factorable, plus 2r plus 2r plus 4, so r of r plus 2 plus, that's 2, plus 2 times r plus 4. And, well, we got r plus 2, r plus 2. So we end up getting a repeated root of r equals negative 2. So our complementary solution is going to be c1e to the negative 2x plus c2x e to the negative 2x. That is our complementary solution. Also should point out, we might need to break this up into two parts because it's going to be a long question. But continuing on, like the complementary part isn't bad, but like we'd be done. We just like plug in our initial conditions, solve for C2, but because this is non-homogeneous, we have like this extra force right here. We need to find this particular part and add it. So let's just create our guess. We know f of x right here is 5e to the negative 2x. And we know that if we derive it, we're still going to have e to the negative 2x, but we're also going to have some constant in front. So this is our guess. But we both need to add these together and, well, call this like a base, for example, like e to the negative 2x times a constant, e to the negative 2x times a constant. Those are the same thing, because you add these together, it's just c sub 1 plus a all times e to the negative 2. And a constant plus a constant is, sorry, a million times, like still a constant. So we actually need to change this. So we multiply it by x. And we look and, oh wait a minute, we have a constant times x times the same base. And that's the same thing we have here, so we actually need to multiply it by another x. So this actually equals x squared a e to the negative 2x. And that is our general form. And now we need to derive this twice. So, I mean, you can see the power rule. So I'm now looking forward to this. I'm going to be really upset if I make a mistake and I have to like redo this video. But let's derive it, because we do need to plug it into this and solve for our constant a. So we get derivative of x squared, one part, two part, times just the normal of the second plus the derivative of the second, so negative 2a e to the negative 2x times just the first. And that is our first derivative. And now we have two more power rules. This is so much fun. So we derive the second times, derive the first times the second plus the derivative of the second times the first, plus, we do it again with this half, derivative of the second times the second, plus the derivative of the second times the first. And we'll simplify this out, and we'll simplify this too, so 2xa e to the negative 2x plus negative 2x squared a e to the negative 2x. That equals y prime. And we'll simplify this too, so we get y double prime equals 2a e to the negative 2x minus 4x a e to the negative 2x plus 4x squared e to the negative 2x plus negative 4x a e to the negative 2x. And this all turns out, this is definitely going to be a two-part video. This turns out to be 4x squared e to the negative 2x minus 8x a, we add these two together, e to the negative 2x plus 2a e to the negative 2x. Now let me just reference my notes to make sure I didn't make a mistake already. Let's see. So, so far so good, I think. All right, so we're still in shape. So, we need to plug these derivatives into this equation right here. And with that, we will finally find yp, then we can add it to yc. And then we still need to plug in our initial conditions. But, if you can do this problem, then you will be set for your quiz or exam, whatever it may be. But we have y prime, and y double prime. So let's plug some stuff in. So we just have 1 here, so we'll just say 4x squared e to the negative 2x plus negative 8x a e to the negative 2x plus 2a e to the negative 2x plus, now this is y prime part, so we multiply it by 4, 2x a e to the negative 2x plus negative 2x squared a e to the negative 2x plus, this is the y part, 4 times x squared a e to the negative 2x, and that all equals 5e to the negative 2x. So, shit, that's a lot. Well, what I can see is e to the negative 2x is a common factor here. So we can just cross all of those out. Makes this equation nicer to look at. we've got 4x squared minus 8x plus 2, a, also, we can't forget our a, that's what we're solving for. So, plus 2a plus 4 times 2 times x times a is 8xa, and then 4 times negative 2 times x squared times a minus 8x squared a plus 4x squared a plus 4x squared a equals 5. Oh boy. So, well, there's no x squareds here. Actually turns out it's just 2a equals 5. Because this is just 0 x squared plus 0x plus 5. So we have like 4x squared a minus 8x squared a. Well, actually, this just cancels out. And then we have like 8xa, negative 8. Okay, so this just cancels out. We're left with 2a equals 5. So a equals 5 over 2. Let me just check with my notes, make sure that's up to date. Yep. So, we can finally finish out our particular solution. Yp equals x squared, well, 5/2 x squared e to the negative 2x. You know, we add that in, and we add that in, and we get our particular solution. So, we have our complementary part, our particular, y equals yc plus yp. So let's just add them together and see what we get. So we get y equals c1e to the negative 2x plus c2x e to the negative 2x plus 5/2 x squared e to the negative 2x. So that is our general final solution. But we're not done yet. We still have these initial conditions. So in the next video, we're going to have to derive this, then plug in our initial conditions, and find out what C1 and C2 are. And once we do that, we will finally have our final answer to this non-homogeneous differential equation, where we find a y, an equation y, where 4 times itself plus 4 times its derivative plus its derivative equals this monstrosity right here. I think I mentioned at the beginning of this series that differential equations are really hard to solve, so you need to get creative. And this is a perfect example, because this is like a good 25-minute problem. But I'll see you in the next episode.